Okay, so we're going to talk about projectile motion problems now. And there are three main things that projectile motions typically ask you about. The number one is going to be time in the air. Now they could ask you for time in the air, or they could ask you simply for time to max height, but we're going to use the same methods to solve for both of those. In addition, they could ask you about range. That means distance traveled in the x direction. And then finally, they could ask you for max height, which is the distance traveled in the y direction. I'm going to show you a way to solve for all three of these things in less than a minute without using a single equation. Now this is going to be a much more effective way to solve these types of problems because not only is it going to be faster, but you're also going to be able to avoid a lot of the ugly math and really long, confusing equations that are usually suggested for solving these types of problems. And this is going to make you much more accurate and really just save you a lot of time on your MCAT. Now the reason why I'm using projectile motion to illustrate this principle is because projectile motion problems are a really good example of translational kinetics. Okay? If you are able to comfortably solve a projectile motion problem, you will have no problem whatsoever solving any type of translational kinetic problem in the MCAT. It uses the same ideas. Whether you're dealing with time, displacement, velocities, or acceleration, you will be able to solve any type of translational kinetics. Some of the most common ones on the MCAT are dealing with cars traveling at constant velocity, or cars braking on the freeway and how far it takes before they'll stop, or skydivers jumping out of a plane and describing how far they'll fall if they fall for a certain period of time. All of these types of questions are going to use the same skills that we are going to develop in this example of projectile motion. So we're going to start off by solving for time. And the reason why we're going to start with time is because if we're solving for range or if we're solving for max height, we need the time in order to find both of those things. So the time is the number one thing you always want to solve for. Now first of all, we've got two components of our velocity here. We've got an x component and a y component. And only one of these is going to determine our time in the air. So now take a second to think about which component of our velocity is going to affect our time in the air. You should have answered that the y component will. Now take another second to think about why the y component of our velocity is going to be the one that determines time in the air. The reason why is because we have an acceleration acting in the y direction that is not acting in the x direction. The reason why this thing eventually reaches a max height, stops going up, and starts to fall back down is because it's experiencing a y acceleration, which is gravity in this case. If that gravity was not there, this object would simply continue forever. And that's not the case, so we know that it is the y acceleration that is causing our y velocity to reach zero and eventually come back down to Earth. Because that's the thing we're most interested in right now for solving for time, we're going to solve for our y velocity first. Okay, and we're just going to use some basic trigonometry to do that. So in this case, the sine of 30 is what we're going to use because we're dealing with the opposite over the hypotenuse. So the sine of 30 is equal to y over 100. So sine of 30 is 0.5, which you should remember. 0.5 times 100 gives us 50. So 50 meters per second is our initial y velocity. Now over time, it's going to lose that velocity to the point where it reaches 0 meters per second at max height and then begins to accelerate on its way back down. But then let's take a second to think again about why it's accelerating. It's the gravity that's causing it to accelerate and lose that velocity, right? And our gravity in this case has a value of 10 meters per second squared, or in other words, 10 meters per second, okay? Now I prefer to think about it this way, even though there is a fairly simple equation that you could use in this case to solve for time in the air, which is acceleration equals change in velocity over time. I prefer to think about this in a much more conceptual way. In this case, we're starting with 50 meters per second of velocity, which is going to lose all of its velocity by the time it reaches max height and has a velocity of 0 meters per second. So ask yourself, how long is it going to take to lose 50 meters per second of velocity if it's losing it at a rate of 10 meters per second per second? So that means that after the first second, it will lose 10 meters per second of velocity and be going 40. After the second second, it will lose another 10 and be going 30. After another second, another 10 and going 20. Another second, another 10 and going 10. All the way to the last second where it will lose all of it. Count them up. It will take 5 seconds to lose all of its velocity. Okay? If you use this equation, you would get the same thing. So it doesn't matter to me which one you choose. I prefer the conceptual one because it tends to be a little bit more versatile in other scenarios, but you can go with whichever one you want. So we're only halfway done though, because so far we've only solved for time to max height. It took 5 seconds for it to lose all of its velocity at max height up here. But we are interested in total time in the air. Total time in the air is going to be symmetrical. So it took 5 seconds to go up. It's going to take another 5 seconds to come down. So it's as simple as 5 times 2. In this case, 10. So our total time in the air is 10 seconds. And we got there without using a single equation. Go ahead and keep practicing this. In our next segment, we will talk about the range.